This is year 9 work, but it's, you know how scholarship is, it gives you a little bit of this and that. And so I just wanted to look at radio decay. We looked at half-lives and stuff in year 12, or maybe we didn't actually. So, you know, when you've got a group of nuclei and you know the half-life, then you'll know that in that time, half of them will have decayed. We can't predict for a given nucleus when it's going to decay. We just have this probability that it will decay in that time, or 50% chance. So let's look at, I just wanted to look at the maths of this. And if we've got a certain number of atoms, then basically what we're saying is the rate at which they decay must be equal to some constant. We'll make it negative because I want the constant to be positive, but they're going to be less atoms, right? Times the number of atoms. All we're saying is the rate of decay is proportional to the number of atoms, right? And so this is our little differential equation that we've got to solve. So if we want to solve that, and I think by now you've done a little bit of differential equations, so you probably know that we can integrate both sides and separate the variables between t and n. And so we can say it's the integral of, so bring that one over there. Sorry, dn can stay there, n can go over here. So you've got the integral of 1 over n, and dn is equal to the integral minus wavelength dt, right? And that becomes the log of n equals wavelength minus wavelength t, so we end up with the log of n, if you like, minus wavelength t, and if we take both sides to the e, we end up with the log of both sides. Depending on whether we took, I should have used an in then, if a natural logarithm, but you know what I mean. It'll all come out right. Then what we end up with at n is equal to n naught, the original number of atoms, e to the minus lambda t. So that's equation for, if we start with n naught, how many atoms we're going to have, or how many nuclei we're going to have. So if we now look at the idea of a half-life, sort of give it that Tor symbol equals half-life, right? Then what we're basically wanting to know is when will there be just half the number left. So that's n naught over 2 must be equal to n naught e to the minus lambda t, right? When is that going to happen? So we can cancel our n naughts. We can say 1/2 is going to be equal to e minus lambda t, right? So again, if we want to get rid of both sides, we can say log of a half is equal to the log of that side. So we now got minus lambda t. We take the minus to that side. We've got the minus the log of a half. That's the same as the log of a half to the minus 1, which is the same as log of 2. So we can say that the log of 2 is equal to lambda t, right? So if we say that, we can say that the half-life is equal to log of 2 all divided by lambda. And that's our, actually I shouldn't use t, I should use that. So that's the half-life formula. Right? Are we good with that? I think we are.